You are welcome back. So now we want to find the derivative of sine x by the first principle of differentiation. Let's go. Solution. The formula for the first principle of differentiation, you know that it is the x is equal to the limit as change in x tends to 0, then f of x plus change in x minus f of x divided by change in x. Here y is equal to sine x, which is the same thing as f of x. So f of x plus change in x will now be, wherever you see x, you're going to put x plus change in x. So we have sine over x plus change in x. Now we're going to substitute this sine of x plus change in x into this formula and sine x here as well. So we have the y, the x will be the limit as change in x tends to 0, then sine of x plus change in x minus sine x, everything divided by change in x. By trigonometry identities, if you have sine a plus b, will be equal to sine a cos b, then plus cos a sine b. So it's sine x plus change in x will be equal to sine x cos change in x plus cos x sine change in x. So I'm going to substitute it into dy dx, which is equal to the limit as change in x tends to 0, then sine x cos change in x plus cos x sine change in x, then minus sine x. Everything divided by what? Change in x. So what can you see? What can you observe here? You can see that there's sine x here. There's also sine x here. So it means that we can collect the like terms together. So we can have the y, the x is equal to the limit as change in x tends to 0, then sine x cos change in x minus sine x plus cos x sine change in x divided by change in x. So from here, sine x is common to the two expressions. So we can factorize sine x out. So the x will be equal to the limit as change in x tends to 0, then sine x into brackets cos change in x, then minus 1. If you expand this expression, which is sine x into brackets cos change in x minus 1, you must have sine x cos change in x minus sine x. So plus cos x sine change in x, everything divided by change in x. So from here we can see that dy dx is equal to sine x into brackets cos change in x minus 1, everything divided by change in x, then plus cos x into brackets sine change in x over change in x. Don't forget your limits. The limit as this tends to 0. So dy dx will be equal to sine x, then multiply by the limit as change in x tends to 0, then cos change in x minus 1, over change in x plus cos x. Then the limit as change in x tends to 0 sine change in x over change in x. Recall, you have to recall that the limit as change in x tends to 0 of course change in x minus 1 over change in x is equal to 0, and the limit as change in x tends to 0 sine change in x over change in x is equal to 1. So we're going to substitute 0 whenever we see the limit as change in x tends to 0 cos change in x minus 1 over change in x. This one will be equal to 0. And the limit as change in x tends to 0 sine change in x over change in x will be equal to 1. So the x will now be equal to sine x multiplied by 0 plus cos x multiplied by 1. So, since any number multiplied by 0 is equal to 0, then we have cos x. Derivative of sine x is equal to cos x. That is how to find it. You can see it is not difficult to do at all. Till I see you in the next class. Thank you. God bless you. Bye bye.